fact that they have to tell you that it's a normal distribution, and that it has its mean that's centered in a particular position, and that it has a standard deviation. So if this was the problem, then I would know for this particular exercise that the center of this universe is at 78. And a standard size step is 12. And we're 1.25 standard deviations above the mean, so one full standard deviation adds 12 to that 78, which takes us to 90. And then we take only a fraction, we take 1/4 of a step. So we then have 90 plus 3, which means we end up at 93. Or if we want to do it the shorter way, starting at 78, we have 1 1/4, which is 1.25 full steps of 12, which we could put into the calculator and come up with our value of the same 93 in the problem. No difference, one to the other. The slide I forgot to put into here, so I want to insert a blank slide in the problem, and we'll build an exercise. The mean weights of a group of automobiles is 2,150 pounds. But not all of them weigh that. There is a deviation with a standard deviation of 175 pounds. Between what values will the middle 95% of automobiles lie? So this problem is targeting a specific application. 68, 95, 99.7 rule. What's significant about 68%? They're within one standard deviation, which means it's the mean plus or minus 1 S of X value. What's significant about 95%? So that's within 2 standard deviations. So that means it's X bar plus or minus 2 of your standard deviations. And what's significant about 99.7%? 3 standard deviations. I don't know which percentage value you're going to get, but I know you will get one of them if they want to target the 68, 95, 99.7 rule. So in your case, if you're doing the problem that was asked in the exercise, then you're looking for 3 increments of S of X, or excuse me, 2 increments. of S of X. So here you would have your 2150 plus and minus the 175. So 2150 minus 2 increments of 175. So I got a little bit hasty on that. 2 increments of 175. Which would take you down to 1,800 pounds. And then you'd have the same thing, but you'd be looking at plus in the exercise. So if you're thinking about a picture of the problem, the picture here basically is giving you from your middle value of 2150, one complete step, a second complete step, so there's the 2500, one complete step, a second complete step, so there's the 1800. And your numbers would differ depending upon whether you went 2, 1, or 3 steps. So just read carefully and make sure you get the right set in there.